a bunch of tools you can use, like an intro to a bunch of things. So it's like a list of kind of unrelated things, tools to put in your tool belt rather than a strategy or themes. So if you're using these, I will not feel offended at all if you walk out. I've had people sit through the talk and say, it was good, but I'm using all those things anyway. I don't want to waste your time. So don't feel bad. If an intro to kind of a bunch of tools is not what you need, feel free to find something else. And with that, I guess we'll get started. Great. So hopefully if you're still here, it's because you want to be here for ECMAScript 2015. We'll talk about what that means a little bit if you're kind of new, but some shows of hands. Who here would say they're primarily a web developer? Okay, who would say they are primarily some other sort? Desktop services, mobile, okay. Anyone not a developer at all? Okay, good, because I have no content at all for, okay. Michael, appreciate you coming anyway. Okay, so hopefully this is relevant to you. Who here knows what ECMAScript 2015 is, or have you heard like ECMAScript 6, either one? Okay, good. So like we're on the right, this is like thematically correct for the people that are here. Some intro stuff around the slide deck. I'm using a tool called reveal.js. It's an HTML-based slide deck. You can pan and interact with it. I'm going to be going to my F12 tools quite a bit. So if you're not familiar with these, and I usually get a few people who aren't, they're the browser debugging tools. All my demos are built just in the website. So I'll be using these. I open them with F12. There's other shortcuts on a Mac. All the browsers have them. I'm going to primarily use Chrome. Chrome is my development platform of choice. Actually, surprisingly, since I've moved back from a Mac, Edge is my day-to-day browser of choice. It's very fast, but their dev tools are still not quite there. So there's certain things that are good about, but we're going to use Chrome today. But this talk will work in anything. You can get it github.com/Jared Faris. There's two repos, ES6 talk and ES6 server. The server portion is not really required, but I show off a couple Ajax things. And so you need a back end to do Ajax calls too. So the talk you can download. There's actually there's a bunch of tooling around it, but you can actually just run the HTML file and work through the talk. So you don't need a whole lot of tooling. You're welcome to take it. There's a license on there. You're welcome to share this. If you can figure out a way to take this and make money, I am totally cool with that. Good luck to you. Also, if you want to add things or make changes, I will totally take pull requests. If you want to do my work for me, I am happy with that too. So enough about that. A brief obligatory about me section. I will try not to waste too much of your time. This is my little avatar. It should be more like that now. I'm a developer from background. I work for a consulting services company in Columbus called HMB. I'm kind of responsible for our .NET and Microsoft Stack team, and I work with customers to figure out what they're trying to do and how we can use technology to solve those problems. So there's that. And I'm involved in some conferences. The first one you may have heard of. Star Trek Today, you should maybe check it out. Also coming up, just to advertise these, Cloud Develop on August 26th is a one-day cross-platform cloud computing conference. It's a little Microsoft heavy just because there's a lot of people who speak about Azure, but we have things about AWS, often Heroku and other topics like that. Things like Rackspace, a lot of DevOps content, things like that that are relevant to anyone. Christian will be doing, I think, a Docker workshop, or has in the past at least. And then DogFoodCon, which is a two-day Microsoft, like any Microsoft technology conference in October. So check those out. They're coming up. So let's talk about JavaScript. And we'll also talk about ECMAScript here. So I know that I'm not very good with graphics. I apologize that the fonts are small. I'll walk you through this. The goal here is to give you a sense of scale. And I should probably have somebody who's good at visuals to do something more. So Brandon Ike invented Java, or Mocha, in Netscape in 1995. So it was they wanted a scripting language for the browser. Everything was just sort of static at that point. Oh, and I need to use these controls. It gets renamed to LiveScript. In 1996, it gets renamed to JavaScript. And then in 1996, they submitted to ECMA. So ECMA is like ISO. It's like a standards body. It's European something. I don't know. So it becomes a standard. And in 1997, I need to quit using those arrow keys. 1997, ECMAScript 1 is born. It's pretty lightweight. I think the joke is that it was built in like a week or something like that. It right out of the box shipped with all sorts of amazing features, like things that don't behave how you'd expect. We'll see some of those, but right from day one, it was weird. The idea behind ECMAScript is it's a standard that describes a language spec. So it's a bunch of behaviors the language will have. ECMAScript has nothing to do with the browser. So there have been other implementations of ECMAScript. Any ActionScript devs back in the day? Right? So that was an implementation. JScript was Microsoft's initial JavaScript. And there were others. Each one of them had their own concept of like the domain they lived in. So JavaScript has the DOM. It's got the window and document and that sort of thing. ECMAScript doesn't care about that. It's just a programming language. And then you bolt on like environmental specific things, if that makes sense. So ECMAScript and JavaScript are often used as synonyms, but they're kind of not. So there's the standard and then an implementation. So ECMAScript 1 lasts for about a year. ECMAScript 2 comes out. It lasts for about a year and a half. So we're up to about 2000 now. So things have been moving pretty quick, but it's a new language, right? It's really easy to move fast in something that's tiny that no one uses. Now it's becoming kind of like web days where people are actually using this. They can't just make breaking changes. ECMAScript 3, which comes out, lasts for a long time. So from 2000, and then we look at Firefox is released in 2002. A lot of things happen up to 2009. Chrome gets released 2008, rather. We go from 2000 to 2010, and we're still on ECMAScript 3. So it's a long time, right? The way they shipped features at that point was, let's figure out all of the features we want, and then we won't release until we define all of them, right? So this is like traditional IT. Like, we're not going to release until it's perfect. Perfect means 10 years, I guess. You get ECMAScript 5, which added some new features in 2009. It lives for a couple years, and you get 5.1. When I talk to people from the Edge team, they kind of joke about 5.1 being a documentation release. Like, it wasn't really like functionally, it didn't add much to the language other than people kind of standardizing on things. It lasts for quite a long time. It's not up until 2015 that we get ECMAScript 6. At this point, the standards boards decide this kind of, hey, we'll decide on the features and then we won't release the spec until they're all perfect. It's not really cutting it, right? The web's moving too fast. Everything in IT is moving too fast. We're going to switch to a process where we release yearly, like on a yearly cadence, and we get to what we get to. So with that, they renamed it ECMAScript 2015. So I will still say ECMAScript 6 sometimes. They're the same thing, but now that you're going to expect a release cadence where you go 6, 7, 8, whatever, 16, 17, 18, 19, 20 with annual releases. This is the standard, though. So the browsers don't implement the standard at the same time. They don't, we'll talk about support. They're going to track behind. So the goal for the standards body is to have a consistent release tempo that then the browser vendors can try to kind of match to, if that makes sense. It's easier for everyone to kind of expect a release schedule. One thing to note, Chrome was released way back here, 2008. The next major new browser to get released is 2015. And Edge is a new browser for Microsoft. That means it's their first new browser in 20 years, right? Abe Bateman, who's the product group lead, I'm a Microsoft MVP associated with like the Edge team. He's the one that's kind of runs that product group. A quote of his that I absolutely love said, "Making a browser is kind of hard." There's a lot of knowledge that no one has. You have a 20-year-old code base. There's things in there that no one understands. When they started working on Edge, they had to kind of like rebuild some of these things where there was no one left at the company that had been there on any team related to this when it was built. Chrome sort of did that too, but they took things that had evolved from like I think Conquer on the Linux platform. Right? These things have a lot of old gunky bits. So when we get to weird behaviors and stuff, and why the web is where it is, and how it behaves the way it is, there's a lot of, well, it's always been that way. It's interesting to talk to the standards body, the people on those panels, because one thing that a priority goal of theirs when they're making new features is not break the web. So JavaScript does dumb things, and if they just change that, everything breaks. And no one wants to go back and fix an application that's been working for 15 years. So there's a lot of reasons to have kind of this wonkiness, and it's probably never going to go away. So that's ECMAScript and JavaScript. Does that make sense? It kind of sets the stage for some of these features that have been in development for quite a long time. But first, before we go into the features, I want to break the ice with some fun JavaScript. And some of these will tie into things we're going to look at, and some are just silly. So JavaScript's object-oriented. What does that code do? Just shout it out. You get this uppercase string of hello. Seems reasonable, right? Well, let's see if that's the case, because it is JavaScript. So if we say hello, .to uppercase, right? You get that. Oh, that's great. Okay, so what does this do? To.toString. Anyone? Yeah, that would make total sense, wouldn't it? No. What to.toString does is break. The reason for that is JavaScript it was built quick, it was built to be dynamic, and it was built to be adaptable to failure, let's say. it tries to figure out what you intend. 2 dot looks like a decimal number. The word toString is not a decimal number. It tries to make 2 dot and then convert that to a number, and it just blows up. But what does work is 2 dot dot toString. Because 2 dot and then nothing, well, okay, it converts that to an integer and then it changes it, right? Because JavaScript is weird. JavaScript has parameters. So you can write code that fits in this function. So foobar console test, no parameters, and then pass it a parameter and it will work just fine. Does anyone know why? Yeah, you have an arguments array, actually. So there's this concept of arguments. That's where the actual arguments you pass in go. You can have a function with 3 parameters and pass it 20 arguments, and you can use them. You should never, ever do that. It's terrible. But there's some stuff coming up in this talk that will sort of relate to that. JavaScript's weird. Type conversions. What does this do?
Makes me cry.
Yeah, it makes you cry. And if you've seen this talk before, you're not allowed to shout out. Okay, let's walk through this, because this is some funkiness. First, oh, that's not what I want. Go away. Okay, so I'm just going to run this in little bits. So, a function, this is a function, right? It's a thing. You can't really run it like that. This bitwise nor, I think it's called, is going to effectively take whatever I passed into it, negate it, and subtract 1. So JavaScript's saying a function's sort of an object, so objects are sort of like 0, and then I'll negate 0 to get 0, and then I'll subtract 1 from it. Yep. This little set of things here then becomes -1. Yeah, it adds them up, right? So it says, okay, well, now those are numbers, so I know what to do with numbers. So then you would think, okay, I have an array, and I add some numbers to it. What's going to happen with that? No, that's not an error. It says, okay, arrays don't actually have a plus operator, but numbers do. I'll just turn that array into a number and add more numbers to it. Well, actually, in this case, it said, okay, when it adds them, it does some string concatenation. It gets that string of 4. So the number gets converted to a string, right? And then you take the whole thing and add it together, and you get 42. Right? Yes. Thank you. Those brain cells are you're never getting back. Like, they're gone. So one more. What does this do? This is a little bit hard to read. Function, variable scope. I have a set timeout. I alert some stuff. Notice down here, I declare my variable afterwards. Let's go ahead and look at an example of this. This is called hoisting. This is relevant to what we're talking about today too. So normally in a normal programming language, you declare variables before you use them, right? That makes sense? You don't have to in JavaScript. It will parse through here, find my text, and effectively put var my text right here at the top. Then when this runs, my text will already have been defined. So let's go ahead and run through this and put my console up. And it can say, hey, I'm a string. So what's happening here? A couple things. If I were to, let me run this again and show you something here. So when it runs, by the time set timeout's called, this has been executed, right? So I said do something in a second. But when I'm at this debugger, let me run this. I'll be doing this a lot. I can ask for my var, and instead of getting not declared, what do I call it? My text? My text. Instead of getting not declared, it actually exists. It said, okay, I'm going to go ahead and create it up there, but it has no value yet. But you have it. It's there. So you can do stuff with it before it exists, if that makes sense. That's a JavaScript thing called hoisting. This is sort of a side effect of the way JavaScript is sort of compiled, or whatever. The browser goes through the file and looks for structures and things like that. And so it does a first pass, and then it does a second pass for execution. I guess like Chrome there's more to it. Because the browsers will try to set things up ahead of time to speed things up. So there's a thing called hoisting where your variables get pulled to the top. This can cause weirdness if you're not aware of it. Like if you're using an I variable in multiple loops, it could exist. You would think normally, hey, I have scope and it'll do what I want. I use var equals 0, loop through, do it again. You get weirdness in JavaScript because it doesn't work the way you'd expect. It works very close to the way you expect, which is worse. So what you end up getting is something that looks kind of like this, where there's an effective var my text up there. So JavaScript's weird. ES 2015 does nothing to fix that. It just adds more sugar to it. So it's still weird, but now it's maybe more useful. So at least that's progress, right? So can I use this stuff before we look at some features? And we're going to go through the high-value features first. And there's stuff in the slide deck we won't get to, but it's there if you download it, like more advanced stuff, just so you have it. Can you use it today? Maybe, no, I don't know. Yes, sort of. It depends. Right off the bat, there's these tables that offer support, and I'm not connected to the internet, but if you Google ES6 compatibility, this is an interactive table. This is being updated all the time. So the browsers, Edge, Firefox, Chrome, are all called evergreen browsers. They're shipping new features, right? But your IE9 users don't have those. So this site or caniuse.com are a great way to see, like, is this feature implemented in the browsers I want? If you have the luxury of supporting new browsers, you can use most everything. But if you don't, then there's some limitations. So there's a thing called transpiling. It's the idea of converting ES6 that you write, or ES 2015, to traditional ES5. So the way this works, I'll give you an example here. So here's a class, and we'll talk about this in more detail when we get to the class section. This is ES6. I have a tool, and I had to restart because I was having some issues, so this will take me like a half second. I have a tool called Babel, which is going to transpile this class in my slide deck to ES5 whenever this loads up. So let's go ES6 talk, and we'll call grunt transpile. And if you pull down the source code, you'll be able to see what it does. But it's using the Babel tool, and it's going to complain about that, but it worked earlier today. And it's going to run it. And now I'm going to have a new file called using classes and this one. So what this is going to do is it's going to add some boilerplate to reproduce kind of the magic of a class. And then down below, I'll have functional code that's ES5. So now it's a function. It's an immediately executing function. This is a pattern people use to do classes. And it's going to have one-for-one matching things. So let me share this like this and pull up our classes. And so functionally, these are going to be identical. It's going to have create class method. Let's see here. Yes, I can. Absolutely. How's that? Is it better? Okay. It's going to be able to work. So down my calling code, I'll be able to say new profile, log the email address, change an email, do something else. And it's going to work just fine because it's going to have written the equivalent ES5 code to do something. So you can start writing standards compliant modern JavaScript now and then transpile it back to support your browsers that you have to support. And then as your users get updated, you can turn off some of the transpiling. So this is immediately useful. It means the code you're writing is simpler and more concise. And we won't get into the details, but there's something called a source map. That means the code you're debugging is simpler and more precise as well. So you can live in this world and let your users live on whatever browser they have. So that's very handy. So it's called transpiling. I won't go into the details any more of that, but it's something to know about. And we ran that. Okay. So some performance questions too. How does this work? It depends. A lot of things are just as fast. There's a whole chart here. You'll be able to go to this for my slides as well. Some things are significantly slower. You'll see like 30 times slower. Some things are actually faster if they're transpiled. It usually doesn't matter because usually the JavaScript execution is not the slow part of your application. Loading assets is the slow part. API calls are slow. Generally, crunching a little bit of numbers or adding, compiling a string, not what's slow. So you generally don't care. But if you're doing something that's really CPU intensive, it does matter sometimes. Okay, so let's talk about some features here and some changes. So variable scoping. Traditionally, there's a missing type of scope in JavaScript. So we have global and function scope. What would you expect as a developer to have other than this? Block scope, right. So JavaScript does some fun stuff. And I think I mentioned this earlier. So if I have the case like this, var I equals 0, I have a for loop using I. Inside of it, I'm setting a value, and I log the value. In a lot of languages, I would expect this to fail, right? J doesn't exist outside the context of this, but not in JavaScript. In JavaScript, there's no such thing as block scope. So this J got hoisted to the top of the file. They're all talking to the same J and the same I. It gets used, and it's still available at the end. This is the worst in loops where you think you're starting at 0 and you actually start at 10 because something else modified the data. The way developers get around this is with function scope. So they would say, okay, I'm going to put my executable code in a function. It has its own scope, and then I'll use the return value as kind of the protected thing, if that makes sense. So if I walk through this and blog this, log it, yeah. If I write this out, log it, it will blow up because inside this function, my var exists. So you got block scope by using functions. So this has been improved significantly. There's two constructs that we can use, let and const. So let is just block scope. If you use the keyword let instead of var, you can just, anytime you use var, you can switch to let. It's going to work the way you would expect a variable to traditionally work. So it works inside of if and else. So inside the mustaches, the curly braces, there's block scope. It works inside of loops. It works inside of switches, but only for the entire switch. So each case statement of a switch can't have its own block scope, but you can have a single block scope for the whole case. So let's go ahead and demo this. So this is going to basically behave the way you always expect it to, and I'm going to talk about this use strict in a minute. So var equals 5, I'm going to do a loop. I'm going to set my var. When I try to write it out, it should error. And my demos are exciting because if they're successful, they fail. So my var is not defined, right? This is what almost every developer always, probably almost every developer almost always expects the behavior to be. And if you use let, it just works. This is something you should just start using today, all the time. Everyone will be expecting the same behaviors instead of some weird outliers. This use strict at the top, if you transpile, it depends on the transpiler. Some of them will wrap stuff in functional. They'll wrap it in a function to give you that kind of scope. I think like other ones will just it'll just use var and you don't know. So you'd have to check your transpiler. What's that? If you don't transpile? Yeah. I have a thing. Let's see it. Supported in, yeah, it's just edge. So IE9 would choke on just a let. So the transpiler might just switch it to var, or it might wrap it in a function, but either way, it would no longer choke on it. So the demo there. Okay, so let me talk about this use strict real quick too, because you'll start seeing this. I don't know why, but the way they decided to tell the browser that you're writing ES6 and not ES5 is the magic string use strict. If you put that in a function or a class, or at the top of a document, any file, everything else in that file will be interpreted using modern standards. If it's not there, it goes away. There'll be a couple exceptions to this. Firefox played around with a script include that explicitly called it out, and for some reason no one else implemented that, and they all went with this magic string. I don't know, it's weird, it's JavaScript, but that's why you see that. That tells it, hey, this is modern code. So there's also something called the temporal dead zone. So when we looked at this earlier, this var would get hoisted to the top. So it would be undefined, but it would exist. This let will not. So this let will get defined right there. So my var should return undefined, and it will. Let will explode. And my cursor is gone, and I don't know what I just did, and everything is ruined. Okay, let's do this again. So let's bring up the console, hit play. See how it says undefined, and my let is not defined. It's telling us, yeah, I can output this, and it doesn't have any value, but I can output it. This won't. So the temporal dead zone, if you're used to hoisting, can cause issues. If you're writing your code the way most of us write your code, is what you would expect anyway. So, and there's some limitations here. So I said switch statements, and it requires strict mode, so it requires this modern standards, but it works in kind of all the evergreen browsers. And I think also Safari, but no one uses that. Except on mobile. So, const. This one is, you would think constant, right? It's sort of like a constant because it's JavaScript. So it creates a read-only reference, and the reference part's going to be important, in global, functional, or block scope. So you have it across all the scopes. The common thing you'll see is people to use like an all caps variable name. It doesn't matter, but people will do that. If you try to change the value of it, you can use it like a variable, but if you try to change the value, it will throw an error, if you're in use strict. If you try to redefine it, it will also throw an error. So, sort of a constant. But there's a little caveat here. Constants are immutable references, so the reference can't be changed, but you can still tinker with the data in it. I don't know why. So, if we walk through this and we log, okay, I'm going to log the title of this book. Let me clear this out here. The title of the book is my book. I can set the title to something new, and I can log it out again, and it works just fine. This code that I've commented, if I tried to change the my book const to something else, this file wouldn't even load because at load time it would error. So it's not quite compile time checking, but it does notice, hey, that you're trying to do something illegal and it breaks. So it's sort of constant. I don't know why. So this can be useful. I don't think these are nearly as useful as lets. There's some limitations here as well. If you're not in strict mode, things just happen all over the place. Some browsers will still treat it like a constant. Some browsers will treat it like a constant without block scope. Some browsers will throw errors. Other ones will just work. So you definitely need to use strict. They're not consistent. Yeah. So that's great, or useful, but not as useful as let, which you should be using everywhere all the time. Classes. These are huge. Who here has tried to do classes in JavaScript with prototyping or immediately executable functions or something, right? Yeah, a lot of hands. So now they exist. They look like this. Keyword class, they have a constructor, you can add methods, right? Kind of what you'd expect. You can do weird JavaScript things. So in JavaScript, you can create functions, or you can store functions and variables. You can store named functions and variables. You can do that with classes, so they're just functions. This last one, I'm not clear why you would ever do this, but it's perfectly valid JavaScript. So you can treat these like the functions you're used to. Let's go ahead and take a look. So I have a class profile. It's got a constructor, takes an email address. This is sort of the equivalent of like a private variable. A common syntax I'll see is underscore email address to say it's private. There's nothing enforcing it being private, but it's sort of like a, hey, don't tinker with me because I have an underscore in my name. Convention-based, right? It's the, you smack the developer during code review that does that. I'm going to walk down here and create a new profile and then log out the email address. So get my email address, exactly what I expect. I'm going to change the email using that method and log that out, right? So that's kind of the behavior you'd expect from a class. So where does this go weird? Because it has to, because it's JavaScript. Classes are functions, sort of, right? I said everything is a function. So if I look at the type of class, this will get a little bit weirder, so we'll be more comfortable. If I look at the type of it, it's a function, but I can't call it like a function. Just because you can't. You have to use the keyword new. So in every other case other than the keyword new, I believe it acts like a function, so you can do function-y things to it, but you can't just call it. So that's weirder, so we're more in kind of normal ground here. They have setters and getters. So let's go ahead and, if I zoom this out just slightly, can you still read it? Okay, because I have more space to work then. So setters and getters. So let's go ahead and just look at this without the console. Constructor here, I'm going to set my pseudo private variable. I have a getter on it. It's just keyword get lets you know that. I'm going to return it. I'm going to set it, and then so you know I called it via a setter, not just called it directly. I'm going to put the string setter in front. And then I'm going to have another getter. So this is a read-write property, right? And then I have a read-only property. Does that make sense? Okay. So let me go ahead and walk through this. I'm going to create. This is my very complex class. It took me weeks to build this, and I'm going to. You're laughing. I'm not joking. I'm going to log that. I'm going to set the get set variable to bar. I'm going to log it again, and then I'm going to try to call a set against my getter, if that makes sense. So this should break like you'd expect. So kind of classic class behavior. That was a terrible sentence. Okay, so getters and setters. Inheritance and subclassing. You have this. It's nice. I have my fake member profile. It extends my profile. And you'll remember profile was my class that had an email address. And I can add new behavior. So get member ID now, instead of returning hi or whatever it was, or it's going to return 1, 2, 3, 4, 5. And when I walk into this, get my fake member profile, I can still call the parent class's email address thing. Get that. I can call my, so I get inheritance, right? Just like you'd expect. So that's nice. They needed that about 5 years ago. But super, this gets a little bit different, or a little bit complex. So you can call members of the parent class. So that's kind of normal behavior. Where this gets a little complex is in the constructor. If you're going to change the behavior of a constructor in an ES6 class, you have to call super for the parent first. It has to be the very first line of the class. If you don't do this, it'll break. After that, it kind of behaves like you'd expect. So my real member profile is going to extend profile, call the profile stuff, add its own behavior, add some stuff to it, and I'm just going to go ahead and log this, and you'll see I get my email from the parent class, I get my numbers, I call change email, and then I write out the new changed email. So inheritance like you'd expect. That super thing, though, having to be called first, only applies in the constructor. Inside a method, you can replace methods, modify them, overwrite them. It's just a little bit of a gotcha. There are static methods. Let's take a look at one of those. And the keyword for them is static. So the static method, so if you think of these static or class method, might be a term you're familiar with. It's not a method on the instance of the object, but it's a method available. It's attached to the class of the object. A common one would be like this days between for events. So this will not have, it will not know about either of the events unless I pass it in, but I can call it from event. So I can say, okay, event 1 is a new event 2 is a new event, event.days between events and do some calculation, right? So math libraries are often built this way. So this would go ahead and just do the math on those two events and give me the days between some stuff. So static methods can be useful if you use them in like your server-side code, or Node give you your server-side code. So those exist. So that's good. Prototypical inheritance. So one thing that a lot of these features that we're seeing really is they're really just syntactic sugar for the way JavaScript used to do this. So classes are just prototypical inheritance made a little bit easier. What that means is I can create two member profiles. So I'm going to say, okay, I have member 1 and member 2. They have IDs 1 and 2. And I'm going to look at their prototypes, and we'll see that they match. Let's do that first. Clear that down here. And I just say, okay, do the prototypes match? I'm comparing this weird underscore syntax to get the prototypes. They do match. It's true. So now I'm going to log the member ID of user 2, right? And it's 2. So now I'm going to do some funky stuff. So I'm going to get the prototype, a reference to the prototype. So I'm going to basically reach into the parent class, and then I'm going to mess with the member ID so that it now returns foobar at the class level, not the instance level. And what I would expect to have happen after that is every instance of this, from now on, will get the same behavior. I just replaced it, right? So this is something, if you use prototypes and they're handy, you can still do. If your eyes are glazing over at this point, it's okay, you didn't need to know this anyway. So I get foobar for both. So you can still monkey about in this stuff, mostly useful for people building frameworks and things like that. But if you're comfortable with prototypes, you don't have to quit using them. And if you're super confused about prototypes, just pretend they don't exist. And I think that's most of us. So some other oddities here. If you use the term class, it's inherently strict, so you don't have to use strict. It doesn't throw an error if you do. There's like a semicolon insertion thing that JavaScript does. If you know what automatic semicolon insertion is, there's just more of it because we like it. Some limitations. As of March, it's supported in basically everything if you require strict mode and weird behaviors if you don't. So if you're supporting modern browsers, you can use this now. If you're using this transpiles very well as well. So you can use this if you're transpiling. Okay, classes are useful and kind of handy and something you could use day to day, but they're not sexy. Arrow functions are sexy, and that sounds weird to say because it's just code, but they are. So, and you'll see it, but not in the first couple slides, because the first couple slides you'll just be like, wow, that's kind of boring. Arrow functions are a new syntax for functions. So, old syntax is the word function, some parameters, and then mustaches, right? These parentheses around stuff. New syntax, parameters, arrow, mustaches. Okay, well that's really not, I saved 7 characters. Okay, not exciting yet, right? But it is slightly shorter. How does it work? It's similar to a lambda. If you work in a language, it has a lambda expression. It can have 0+ parameters. It can be saved in a name variable like a function. I left out of here, you can, if you have one line, if your arrow function has only one line, it will return the result of that line. So that should be familiar to people who write CoffeeScript or a lot of other languages. So you can do kind of cool functional stuff like we see where you don't have to use the return keyword. So there's 2 primary benefits. It's terse, it's a little bit shorter. And then lexical this, which we'll get to, and if it doesn't mean anything to you yet, you'll be very excited in a minute. So let's look at shorter functions. We'll save the best for last. So here's kind of a traditional thing, and I need to do one thing because I turned my server off, and you can't do AJAX against localhost, so okay, it's up. Okay. So I'm going to call a get. I wrote my own little version of jQuery's get or something, so I don't have to see all the AJAX-y ugly syntax. I'm going to call my server. I'm going to call people. I'm going to get a list of people, just some JSON data back. And then I'm going to log it to success. I'm going to parse that data. And then for each user, I'm going to write their username out to console. So nothing super exciting, just kind of something you do a lot, right? Call some API, get some data, do something with the data. So hopefully that's comfortable and you're used to it. Let's walk through this. Breaking my debugger there. And get my parse data. Data is some object that's got a bunch of stuff in it. That's great. And then I'm going to go ahead and write that out. Okay, so this is the type of thing we'll build a lot, right? We call some API, we do something with the data. It's a little terse, but it's not terrible. One annoying thing here is we have this error. So if you had multiple async calls, like call some API, get some data back, parse it, call some other API, you start to get this chain. Let's look at a shortened version. This is not life-changing quite yet. Instead of function, I pass in data. It gets a little bit better here. The for each, I can kind of write this as a one line. For each user, console.log username, user.username. That's a little bit better, right? That's closer to English, like closer to the way we think. So for each user, do something. Not great, not life-changing. And then I have the error handling. And this will do exactly what we're thinking as well, and write some stuff out. So making progress. It's slightly better. Notice that I used an arrow. That's like that was a joke. Thank you. Okay, so cleaner syntax. It gets better when we do functional programming. So these are some built-in things. This is really handy with underscore or Lodash. I have an array of people. I can do people.map function person return person.name for each function name. I can do this kind of thing, right? And define new functions. They're anonymous. I'm just using them once and throwing them away. This is a lot better, right? Map person to person name. And because it's a single line, it inserts the return for me. So I don't have the parentheses, I don't have the semicolon, I don't have the return keyword. For each name, console log name. So that's better, right? This feels just, you can look at that and kind of parse it and see what it's doing. So that's nice. It gets very nice when we start to have a chain. I'll show you this, but let's talk about lexical first. So when we say lexical scoping is scope defined by where a function exists. So you're writing in code, and you put a new function there. Lexical scoping would say, hey, I'm still in kind of the scope of where my outside parent function would be. Dynamic scoping would be scoping based on the state of the program and execution. In JavaScript, traditionally, you can kind of generally have lexical scoping, but not always. Depending on how you refer to a function, this may change. Who's been burned by this? Where this, a lot of hands, right? You click a button, and you want this to be the button, but it's the window. Or you do an AJAX call, and this becomes the document and not some function, right? If you haven't been burned by it, you're extremely lucky. This is confusing. Let's look at an example of the confusing in case anyone kind of hasn't run into this. And we'll look at a hack that we all probably have done to fix it. So here's our kind of traditional code. I do my get. I have a function called writePersonDetails, right? I'm going to call this .writePersonDetails of the data I get back. And when I walk through this, it will break. Right? This is something that happens a lot. We get, oh, it's not a function. So then we debug it. And we say, okay, what's happening when I get to, let's see, right? Oh, I don't know what I clicked, so we're just going to jump to this line. We're going to try to jump to that. There we are. And I'm just going to look at what this is equal to. I'm expecting this to be that function. Oh, it's the window. The window does not have writePersonDetails. Crap. Okay. So what we do traditionally is we write a little bit more code. And so we say something like this. Self is equal to this. And then I'm going to call self.writePersonDetails. Or that is equal to this, because that gets really, really confusing. You have this and that in a code. This is a common hack. So I'm grabbing a reference to the context of this at the time I'm calling the function. And then I'm going to use that from that point on. Including, in fact, the Knockout.js documents for a long time recommended this. I don't know if they still do. But that was their solution to this problem. So if I do this and I walk through and I hit the debugger, if I ask the browser what this is, I get window, not history, this. And if I ask the browser what self is, I get the button. Right? So that was a hack. It works. It doesn't blow up. We get our users, but it's a hack. This is where the arrow functions get awesome. So I'm going to get down here. My AJAX get, instead of using the keyword function, uses an arrow function. Inside these mustaches, or these curly braces, this is exactly, this sentence doesn't work. This is exactly what I think it would be, or this is exactly what this should be in this context. You kind of get what I'm saying? So I'm going to walk through here, and I'm going to ask it for what this is. And Chrome actually used to lie about this, but I think it's correct now. It's still a button. So I don't have to have self. I don't have to have that. The arrow function automatically made the inner context the same as the outer context. And so it just kind of works. So that's huge. That means that you don't have to put a hack in for it to work the way you just assumed it would work the whole time, right? So this actually cleans up, this feature actually cleans up a little bit of the weird behavior that JavaScript had. So yay. So when you use this, when you're creating reusable things that should have names, that should exist for a long time, use functions, right? When you're creating subroutines, callbacks, you're doing functional programming, use arrows. So the kind of throwaway things where the fact that it's a function doesn't matter, it's sort of like your brain is just saying, do this next step, arrows are great. If you're building libraries, like named functions are often better. And it's really good when you're chaining things. You can also do this, immediately invoked arrow functions. So you can define a function and then call it. I don't know why, it's just kind of funny, but it's totally useless. But you can do it. So some limitations, supported by basically everything at this point. So you can use it. And if you transpile it, it works really well because all it does is that is equal to this kind of thing. So you can kind of use this today, even if you support old browsers. So this is a big win because the that thing has been an issue for JavaScript devs for basically forever. And it goes away. And it's terse. So far, you with me? Going to go through a couple more things pretty quick because we have about, what, 20 minutes and leave some questions. So promises and futures. There's two concepts here. So future is a value that we know exists but will be set at some point in the future. And a promise is a function that will set that value. So these exist in ES6 now. They're really useful in asynchronous programming. So let's look at an example. And lets you, let's say, proxy something that hasn't been set in code. It lets you act as if something is going to exist that does not yet. So don't want to cough in your ear. So, okay, useful for reducing callback chains. So let's look at this. Async call, so like jQuery get some data, pass some data in, get the data back, do something else. Call another jQuery, right? This could be a dashboard. Load the person's information. Okay, I have their person ID now. Now load their shipping history. Okay, I got that back. Now load the tracking numbers. Okay, I got that back. This is called a pyramid of code. Right? Pyramid coding, you see how it kind of indents in and indents back out. This is not uncommon in JavaScript. And callback hell is another term I've heard used for it. Promises help you with that. You can do things like this. Async call, then with the data do something, then with the data do something else. Another big benefit, in this code, I may have error handling every step of the way. So each function I'm calling would have the success callback, and then I would immediately follow it with a comma, error callback. I often don't care about that, right? If I'm loading a dashboard and I'm loading 3 bits of information for a user and it fails, I'm probably going to pop up one message that says, hey, reload the page, or hey, contact support, or like a fail whale or something. I don't care to have 3 layers of error handling. And I don't necessarily want to write a try-catch around this whole thing. So you can put one error handler at the end and do appropriate things with it. So this is kind of the idea of a promise. It's a tool for letting you do these kind of asynchronous things, and it will pause and wait for the first thing to finish, and then it will execute then. Does that make sense? See why this would be useful? So let's go ahead and try this. I keep hitting my key. So I am going to have write person details. I rewrote my jQuery Lite library to return a promise. And I'll show you that in a second. And then when I get it, I'm going to say then do some stuff. So then I can walk through this. And if I had any errors, I could catch those errors and I could return it. So it's not much more efficient with like one layer of indentation, but it's a little clearer. Let's go ahead and look at what the promise get does. So we'll just do this again. Let's step into this. Right there. So all this does is instead of returning a value or something else, it returns a promise. You see the end, I return the promise. And then in the promise, I have a function. And I can do what I want. And then I have a couple keywords here that matter. So I have this resolve and this reject. So resolve will say, hey, this was successful. I'm going to pass back data. Reject says, hey, this was a failure. I'm going to pass back other data, usually error messages or something. This will then tell the promise on the outside to execute the next thing in the chain. If that makes sense. So you can write these pretty easily, and a lot of libraries already return them. So if you use like jQuery's deferreds, or there's other libraries that have promises, this concept may be familiar to you. So these can be pretty handy. They have a behavior, so you can attach things to promise chains dynamically. So as the user's doing something, you might decide, hey, I need to make a call to you're a financial institution, and depending on what they do, I need to make a call to an identity check thing. And then, depending on some other data, maybe I have to do a credit check. Maybe this stuff is happening in real time, and you're sort of deciding in the browser it has to happen. This may be a bad example from a security standpoint, but bear with me. You can attach more things to the chain. So you can have other JavaScript code attach more .thens. If the promise has already succeeded, it will immediately fire the .then. So you don't have timing delays where if I attach the then and it's already happened, it just never runs. Does that make sense? It'll sort of behave the way you'd expect. If something has succeeded, anything else ever attached to it will automatically fire. So let me walk through this. And this is important because it prevents side effects, but it's kind of weird. So I'm going to attach a then, and I'm going to write some data out. And then I'm going to set a timeout. So it's going to wait 3 seconds. Then it's going to attach another then. So my promise will have already succeeded at that point, if that makes sense. So this first operation doesn't take 3 seconds. When this happens, you'll see in the console, it'll immediately write the results out. So in fact, I'm going to take this out so you can see it happen. So we run this. Run this again. Okay. So when I hit this go, the first thing's going to write, and then 3 seconds when the other promise is attached, it just writes the output out. So this means if you're doing chaining, you never get any sort of timing issue where something didn't fire because you attached it in the wrong order. So it protects you, but you don't usually think about it. Hopefully that makes sense. Undo this. Changes, I can't, whatever. All right, next slide. So support, again, Edge from Firefox Safari. It works as long as you're using strict. And there's no real oddities there, so that's non-traditional JavaScript. Default parameters. So remember I talked about the arguments array earlier? This is where this plays into it. So now in ECMAScript, you can insert default parameters. This is one of those things that you may have strong feelings about. Some people think these are always terrible. If that's the case, don't use them. But they're available to you. In Firefox and Chrome, the last time I checked. I don't know if this is out in Safari yet or Edge. So we can demo this because we're in Chrome. So if I pull this thing, I'm going to run through here, and I'm going to basically concatenate 2 words. And so it doesn't break if you don't give me a second word. I'm just going to insert blank, and then I'm going to log out my outputs. So just run this first, and then we'll talk about a couple complexities here. So I get foo, and I get bar. So when I ran this code, I stepped into string concat. I passed in the first word. It, because it didn't have a value, gave it a default blank, and then added them together. Does that make sense? So it's important to know this is evaluated every call. So if I mess with the value of second word, so if I screw with the default value of the parameter or the value of the parameter, it will reset to the default for the next one, which is what you'd expect, but it's kind of worth talking about the fact that it does that. So you can mess with these values and tinker with them and not break future execution, which is what I'm doing here. I'm setting second word to be plus equal to the first word. So default parameters, they're useful sometimes, and they exist. Template strings, I think, are useful more often. So these, and we're running out of features and we're running out of time, so this works out well. So string formatting in traditional JavaScript would be something like something wonderful like string. Let's do string. Hi, my name is, and then I'd add in some variable, right? Name, and then I'd go back to and I'm here, or whatever. I'd do something like that, right? Pluses, and I'd have this chain of things, and it's messy, and that's going to break because I don't have a name. So with this new syntax, you could do something more like a string.format in C#, or a lot of languages just support this inherently. The key here is this backtick. So the backtick tells it this string is going to have formatting built in, templating, and then this $, curly brace piece is the next part. That tells it that what's in between those curly braces is code, and it's going to evaluate that code. So it will generate a string that inserts the error number and inserts the error URL, or we can run this one. It'll do some math. It'll say 2 + 2 is equal to the actual number that you get from the math of 2 + 2. So 2 + 2 is equal to 4. So this is handy if you're building an alert that needs some HTML with some string embedded in it, or you're concatenating names and values, or anytime you're trying to build something into a string that has any sort of data. This is very, very handy because it's much easier to read, and the IDEs color it appropriately so you can tell what's string and what's not. Basically every IDE seems to support this now. So another template example. This is useful for like our username thing, and you can even see Chrome shows it to us in a useful manner. This is code, this is code. When I write this out, I get the same kind of thing I was getting earlier by doing the ugly string concatenation. So I think you can use that now in all the browsers too, but I don't have that slide, so I don't remember. Generators, we're going to touch on this briefly. This is probably only useful to people building libraries or doing some complex stuff, but I want you to be aware that it exists. But they're kind of confusing. So there's a concept of an iterable object, so something you can iterate over. So an array, you can iterate over the characters or the values in the array. A string, you can iterate over the characters in the string. Does that make sense? You can walk through and get each one and do something with it. In ES6, they add a protocol for that. So there's a standard way of making something iterable. And if you do that, you can use a new syntax. So for x of y. So if you have a persons array or a people array, you can say for person of people. So instead of having to do a for loop, well, let me show you instead of what we're changing. And it's built into a lot of types. So here's what we do before. We would say, okay, for index and all users, let user equal all users index. My touchpad just quit working. Okay. Let user equal all users in index. So now I have access to the user, and then I can do stuff. Right? So this is a real common pattern. Now you can just write what you kind of want anyway, right? For user of all users, I have access to it. So what that implies is that this is iterable. So one way of generating iterable things with a generator. Does that make sense so far? This is built into a lot of types, so it just kind of works now out of the box, but you can do this yourself. Generators are not the only way to do an iterable, but they're a powerful kind of new concept. So generators are code that can pause, which means they can run through, they can yield a result, they can pause until you need them again. And then they get resumed with the keyword next. And they allow you to do like asynchronous code or repetitive code in a clear manner. So you can take some of the ugliness of your code, stick it in a generator, and then the caller can be really clear. It can do that for of syntax or something else that's very, very clear. The for of effectively is just calling next each time it goes through the loop. And then the generator is yielding a value. It's putting that in the for user of people. It's yielding that into user, doing its thing, and stepping back through. So it lets you make these iterators easily. So let's go ahead and look at a demo of this. There are a lot of demos of this on the web where you look at it and you're like, that's not any cleaner than what I was doing before. So this is kind of a hard thing to wrap your head around from a value standpoint. So see this star here? This is the keyword. This star or key character. This star tells it this function is a generator, so it's going to create iterable, and it has a couple rules. So I have a fragment list item. This is actually going to search through my slide deck for all of the bullet points that appeared when I clicked next. So all of my appearing bullet points. It's going to get these fragments. It's going to loop through them, and it's going to yield a fragment. So basically it's going to catch each one. And then it's going to pause. And it's going to wait until I ask for it again. So if I say, hey, give me the next fragment, it's going to return it. So if I walk through this into my generator, I'm going to take 5 of them. So I can use this for fragment of fragment list items. If it contains visible, count it. If not, do something else. And each time I pass through this, it's going to step into my iterator. It's going to do something. It's going to hit the let, and then it's going to, or hit the yield, and it's going to bounce out. Go to my call code, and it's going to go through it again until I quit asking for it. So each time this for loop is asking for it, it's going to go back to the iterator and resume where it was. It doesn't run line 7 again. So you can have like setup code that runs one time and then pauses and stays in the state it was in until you want to use it again, if that makes sense. So you traditionally have to handle this some other way. It'll loop through this like 5 times and then it'll output. So the key thing here is that I can have a service making a bunch of API calls. I can have something that's decrypting a document. I can have something pulling data out of some other format, like an EDI document that I want to map the next key or something. I can iterate through something and work with it. So, okay, next thing. So when they're useful, anytime you want to use that syntax for of, when you want to build complex things that parse, anytime you think I'm going to parse this thing into something else, they're useful. Anytime you wish you could pause, there are times where it's like it'd be just really nice to leave this thing in the state it was in and come back to it later. Modules, we'll be really brief about this. ES6 defines a module pattern for loading JavaScript dynamically. It's got this syntax: export a function with some name, and then import that function from somewhere. I don't have a demo because you can't use it anywhere. I think Chrome supports the import but not the export. I don't know why. They're in the spec. At some point I would expect them to be implemented, but they're not really useful now. So if you download the slides, there are a few other things. There's pages. Basically, the slides are HTML. There's other features that are commented out that are kind of niche things that you might want to use. But hopefully this has been a useful overview. Are there questions in the 5 minutes we have remaining? Or are you all asleep? You might be asleep. Yeah, I think I see a hand. Do we get anything like namespaces? Do we get namespaces? Not really yet, I don't think. I wonder if that might be in future specs, but I'm not sure of anything at the moment. I'll have to look into that. Maybe see if I can add that next time. Yes?
So if you're using transpiler, do you ever have to use strict on it? Or all that being handled?
I think, okay, the question is if you're using a transpiler, do you have to use strict? I don't know that the transpiler will know it's ES6 if you don't use strict. So I think you do. I think you need to write standards compliant ES6, which includes usestrict. Any other questions? I'll hang out in the hallway afterwards. I can't necessarily see all the hands either, so catch me in the hallway if you have questions. I'm happy to chat more. Thank you. I'll put links up at jaredthenerd.com. I appreciate your time.